Hello. Now question is we have to check whether a given function is continuous at given point x is equal to 3 or not. For that function is given in two parts. For x not equal to 3 function is x square minus 9 upon x minus 3 and for x is equal to 3 function is 8. So here less than greater than is not given. So we don't want that left hand and right hand side limit. Here function is given in two parts, x is equal to 3 and not equal to 3. So how we can check whether function is continuous at 3 or not? Condition is f is continuous at x is equal to 3 if limit x tends to 3 f of x is equal to f of 3. Now first let us find this part f of 3, which is simple. So what is meaning of f of 3? F of 3 means value of function fx at x is equal to 3. Now in which part function is given for x is equal to 3? Here. So for x is equal to 3 function is what? 8. So that means f of 3 is what? At x is equal to 3 f of 3 function is 8. So one part is over. This part is over. Now we want this part, that is and limit x tends to 3 of fx. Now limit x tends to 3. We know meaning of limit. When we say x tends to 3, x is coming closer and closer to 3 but not exactly equal to 3, right? X tends to 3, that means x is coming closer and closer to 3 but not equal to 3. So that means by definition of limit, here x is not equal to 3. It is very close to 3 but not equal to 3. So here now check where function is not equal to 3, x is not equal to 3. So here x is not equal to 3. So for that function is given this. So write this function as x square minus 9 upon x minus 3. Now check here, if we write x is equal to 3, 3 minus 3 is 0. And here 3 square is 9, this is also 0, 9 minus 9 0. So when this is 0 upon 0, now 0 upon 0 is not 0, right? So when this is answer is our 0 upon 0, we have to simplify this. So here find out factors, x tends to 3 is given, so we will get x minus 3 here and here, cancel out that. Okay, so first find out factors. So this is limit x tends to 3, x square minus 9 we can write as this 3 square upon x minus 3. So limit x tends to 3, a square minus b square is what? A minus b into a plus b upon this x minus 3. Now we can cancel this x minus 3, but cancel means we are dividing both by x minus 3, numerator and denominator. So when we can cancel this, we can cancel some a, that means we can divide by some a if that a is not equal to 0. So here prove that this is not equal to 0. How we can prove? As given that x tends to 3, by definition of limit x is not equal to 3. X is not exactly 3. So x is not equal to 3. Now x minus 3 is 0 when x is 3, exactly 3. But this is not 3. So x minus 3 is not 0. And as x minus 3 is not 0, that means like a is not equal to 0, divide both sides by a. That means we say that cancel this x minus 3. So cancel out this. So remaining is limit x tends to 3, x plus 3. Now put x is equal to 3 because we are not getting upon 0. So answer is, you can write here x is equal to 3 plus 3, that is 6. This is equation 2. So answer of this is 8 and answer of this is 6. These two are not equal and so function is not continuous at x is equal to 3. So from 1 and 2 limit x tends to 3 f of x is equal to f of 3. Check this 6 and 8. So they are not equal. So right, not equal to. So we can say therefore f is not continuous at x is equal to 3, or we can say f is discontinuous. Not continuous means discontinuous at x is equal to 3. Now here think on this. Why we write x is equal to 3 when x is not equal to 3? So that is general question of students. X is not exactly equal to 3, but by definition of limit x is very close to 3. So to find the value of function, value means what? Limit of function. We write x is equal to that given value, that is 3. So limit of this function is 6. Again this function is not 6, but as x tends to 3, function fx tends to what? 6. So 6 is limit of this function. So to find the limit of function, we substitute that x is equal to given value, that is limit. Okay. So here our answer is f is discontinuous at x is equal to 3. Okay. Now in this small question, first part, we have to check whether this function is continuous at x is equal to -2 or not. Now as we saw second and third part, in second part function is given for x less than something, greater than something, in two parts. In third question also it is given for equal to, not equal to. So function is given in two parts. But here function is given not in two parts. This is the function. We have to check for x is equal to -2. So how we can check for this? Here first read the question properly. This function is a polynomial. Okay, so we can write here as fx is a polynomial. Okay, now every polynomial is continuous for all x. Just we have to check whether function is exist for all x or not. That means what? If function is given x plus 3 upon x minus 2, this is polynomial, this is polynomial, but here when x is 2, this becomes 0. So f of 2 is not defined, right? So we can say function is continuous for all x except at x is equal to 2, because for 2 this is not defined, but here upon, like this is not given, so upon we can say 1 is there and 1 is not 0 for any x. So here we can say this function is continuous for all x, and that means also this is continuous for x is equal to -2. So right here as fx is a polynomial and polynomial is continuous for all x. Okay, therefore fx is continuous at x is equal to -2. You can solve this for -2, right? So f of -2 exists. If case is suppose f of -2 is not defined, then we can say this is not continuous. Okay, at that point. But here in these types of sum where function is not defined for some x, at that point only write fx is not continuous. Here this is polynomial and so continuous for all x, and so it is continuous at -2 also. Okay.